So this video is going to go over mirrors, ray diagram rules. Okay, so we are going to go through each of these rules. I'll draw them and we will color code them. Okay? All right, so just to prepare, I did use my handy dandy large paperclip compass. If you want to do it with a small one, that is fine. And if you want to do it with the paper one that I made up with the 2 dots, you can do that as well. Or you can just watch and use the printed off ones that I put on the Google Classroom. All right, so here is my mirror. I'm going to do concave mirrors first. And excuse me if I say lens, just know I'm always talking about mirrors. This right here is my focal point. This right here is my center. You can kind of tell from the picture, that isn't the center because it's not equidistant. I don't want to mess this up with, putting a bunch of labels on here. So I need to choose a location for my object. I'm going to choose my location for my object past the center, and I will make it 3 lines high, which is approximately 2.5 centimeters. I'm just saying that so that if you want to follow along, you can do yours 3 lines high, but they're not each a centimeter. And I'm going to try and draw this perpendicular. Okay, so there I'm just going to draw an arrow. So here is my object. And like I said, I could, put labels on this, but I just really want to pay attention to the rays. Okay, so the first ray. I'm going to draw all the rays from the tip of my object, or the top, all right? And so that wherever those rays converge will be where the top of the image. And then again, we just draw it down perpendicular to the principal axis. All right, so the first one we're going to do is the red one. The first ray. A ray that is parallel to the principal axis is reflected through or appears to go through the focal point. Now, the appears through, all the stuff kind of in brackets after, has to do with different situations or diverging mirrors, convex. All right, so let's do that first one. So here we go. Draw my ray. Here it is. It gets reflected, pivot along here through the focal point. Make sure you don't go through the center. It's the closer one. And I'm always going to draw a little bit longer. My marker is thick. If you want to use a pencil, like I said, that's better. And I'm going to draw, I don't really know where it's going to appear. Unfortunately, I might be running into my diagram down below, but I was trying to fit everything on one page. So here is the ray. It's going like that. So comes in, reflects. So that's rule number 1. Parallel gets reflected through the focal point. Maybe I'll make that there. All right, so now the next one is actually the opposite. A ray passing through or appearing to pass through the principal focus is reflected parallel to the principal axis. So I'm going to do that one in blue. So now this time I start from the tip, and I always draw it a little bit further away. This one goes from the tip through the focus or focal point. Remember, we always have to go to the mirror because the mirror is where the reflection occurs. So here it gets reflected. So I'm not concerned about this point. What I'm concerned now is now it's going to reflect off the mirror, and it's going to reflect parallel to the principal axis. And this is where I use the lines to know that my line is parallel. I'm not going to draw it like that. Parallel to the principal axis has to be parallel to these lines. So sometimes it's easier if you use the bottom of the ruler because you can see if you are going to line up with that line that's a little bit closer. So take some time and make sure that's right. You start at the mirror and then draw. And you want to draw it till you cross that line. Not here, okay, but here, because this right here is incident. It becomes reflected once it hits the mirror, and it's going to go in this direction. So I've done 2 rays. They converged on this point. This should be the top of my image. But I still have a third rule here. Okay? The third rule is a ray passing through or appearing to pass through the center of curvature is reflected along the same path. If we did this right, all right, I should have all 3 lines converge on the same point. Sometimes they're a little bit off. Like I said, it depends on how careful you are. So here we go. I'm going to go from the tip of my object through the center, and I can see here it's a little bit off, right? And I'm going to go through there, Okay. And here are the first one. It comes through, comes along the mirror, and so this one is going to go and then is reflected back. So you can see they don't exactly go all in the same area. They're pretty close, all right? So now this is where I'm going to take my line, my ruler, and I'm going to do a vertical line because this is my image right here. Okay, and if you want to do it in a different color, you can. I'm not sure what colors I'm left with. Here is an orange, if you can tell the difference. Okay, so here is my object. Here is my image. It's right here. Okay, so now, your textbook, I'm not sure if it calls it malt. Sometimes it's called malt. Sometimes it's called salt. But essentially, we want to examine the characteristics of the image. All right? So what does malt or salt stand for? Okay? M-A-L-T. Like I said, sometimes you'll see it. I used to call it salt. So M stands for magnification. If you see salt, it just stands for size. So is the magnification bigger or smaller? And you can see right here, it's going to be smaller. It's going to be less than 1. If you want to do measurements, we can do measurements. Okay? The A stands for attitude, and I can write this at the bottom of the page after. So M is magnification, A is attitude. Is it the same way as the object? So no, it's inverted. So you can say upside down, inverted, flip. They all mean the same thing. Okay, so it's inverted. Okay, or flipped. So A stands for attitude. Yes, Miss Gork has attitude, and so do you probably. All right, now L stands for location. You can physically measure this, or you can just do it with the characteristics of the mirror. So remember, this is the focal point, okay, and this is the center. So what we can say is the image is located between C and F. Okay, between the center and the focal point. And the last one is type. What type of image is it? Well, is it real or is it imaginary? You have a 50-50 chance. But if there's no dotted lines, it means that those rays of light actually do converge. So in this case, it is real. Okay, so malt, magnification, attitude, location, type. So now we're going to do another one. But this time, I am going to choose a different location for the object. So if you need time I'm going to use the same rules, always apply, all right? But I'm moving where this object is. All right, so I did the same thing. I used my big paper clip, did my curvature, label my center, and then I measured. You have to measure that length to the center, and it's 4.6 centimeters. So I've done 2.3. And see, maybe that's my problem. That's not quite, it's a little bit less than 2.3. When I do this in class, I should have done this on graph paper. I couldn't find any. I usually do it on graph paper so we can just count squares. But I wasn't sure how you guys were going to draw your curves, so we did the paper clip. All right. So if you need time to draw that, pause here and you can catch up. Okay, so for this last one, I am going to, the last one of converging lenses, I chose to put my object just in front of the focal point. Okay, so here it was beyond the center, and now here I'm going to go closer than the focal point. There's essentially, how many different places? 4, so 3, 4, 5. You can put your object here beyond C, you can put it on C, you can put it between, you can put it on F, and you can put it in front. So that's 1, 2, 3, 4, actually 5. Once you can do those 5 ray diagrams, you're actually done. And if you want to cheat, page 421 in your textbook actually does 5 different versions. You should be able to reproduce these. All right, so I'm just going to do these in pencil so they're a little bit finer and I can still color them afterwards. All right, so the first one is parallel to the principal axis gets reflected through the focal point. Now don't forget the focal point is here. It's the closer one. All right, so here we go. It comes along the principal axis and then it gets reflected through the focal point. I don't know if hopefully you guys can see that. My pencil line, I don't think you guys can see it. Maybe I'll do it. I wish I had red pens. Okay, so here I'm just going to do this one here. Comes in, it's going to reflect through this point right here. Okay. So I'm just lining it up. All right, so it's going to reflect and it's going to go in this direction. All right. Now that is from there and backwards. Now, that's rule ray number 1. I'm just going to put the 1 there just because the markers are so chunky. All right. All right, so the next one, a ray passing through or appearing to pass through the principal focus. Now, that's very close to it. So now it's going to come through the principal focus. So we have to appear it's coming from there. And it's going to get reflected parallel to the principal axis. I know this one is tricky. So here we go. All right, so this could be, it's going to come from here, but once it hits the mirror, this one goes parallel to the principal axis. And you might say, but Miss Gorick, those do not hit each other. And I'm going to say, you know what, you are absolutely right. But if you remember back to the plane mirrors, if your eyeball, okay, is over here, it's going to follow these 2 lines backwards because you know that these are never going to meet. They're actually diverging from each other. But what you need to do is your eyeball thinks that that light is actually coming. I did a bad job. Look, that's not parallel. Okay? So your eyeball thinks the light, and I'm drawing these with dotted lines, thinks the light is coming from back here. And this one here follows along that. And oh, I did a bad job. Follows, and you're going to do a dotted line. Oops, didn't do that blue one quite. Oh, no, I did. And now this point right here is the front. Or top, not front. And here we go. Let's draw in our, maybe I'll do this with a dotted line because this is a virtual image. Virtual image. Because these rays of light are not really there. Our eye just thinks they're coming from there. Now, can I use that center one? Actually, I think I can. Sometimes you can't use that one. If this object was right on the center, I couldn't use that one. If it was right on the focal, then that's tricky too. So you can see right here, if I do that third rule, I guess I should, what was my color coding? Number 2 was blue. That one was this one. So from the focal point gets reflected. And my last one is green. It should go right through there. It looked like it was. So it goes right through the center. Ooh, not bad. I think I was more careful with this one. All right. Now, that one actually should be dotted too. Okay, that's number 3 because it's going to reflect and go back. So this should be dotted. These all should be dotted. And they actually do cross all there. So now, let's do our mult. Sorry, mult. So this is magnification. So you can see right here, it's much bigger. So it's greater than 1. All right, attitude. Essentially, attitude. Okay, it's upright. L, location. All right, now, if you want to do it in terms of focal lengths or lengths away, so we could see, because remember every 2.3 centimeters, right? 2.3, 2.3. So it would be beyond C. Okay, so beyond C, behind the mirror. Okay, and so MALT is type, stands for type. Okay, and type, is it virtual or is it real? It's virtual. Oops, sorry guys, off the screen. Okay, M stands for magnification, greater than 1. A stands for attitude, it's upright. They're both in the same direction. L stands for location. I measured a little bit away. It's one beyond 2 focal lengths away, behind the mirror, and it is virtual. Alrighty, so there was some handouts on there, so you can print them off. If you can't print them off, you can do what I was doing and just choose different locations. Use your paper clip or a compass to draw. Now, some of you might think, oh, well, does it really matter if this is a circle? Well, it does matter, because if this is not a perfect circle, then you don't know where to change direction of your rays. All right. Virtual images, I think, are hard to locate because you're always concerned with reflecting off the mirror, and then you can see they're not converging. Well, then you have to look and see, where are they going to meet? And sometimes it's behind, so you have to extend your rays backwards. Okie dokie. Hope you enjoyed that.